So the main topic of this lecture is the OWL project property characteristics. So by that, the OWL, right? This OWL allows the meaning, right? The meaning of the properties to be enriched through the use of property characteristics, right? So there are many property characteristics you can use. But one of them is called functional properties. As you can see here is the functional properties. And inverse, so let's see, the functional properties, right? Another one is called inverse functional properties. And the next one is the transitive properties. And then let's see, what is the next? Next is reflexive and irreflexive properties, and etc. Right? Oh, and then one more, the symmetric and asymmetric properties. Okay. In this lecture, I'm going to only focus two of them. Okay, and then I'm going to just cover the theoretical, foundations. I'm not going to implement anything because I need to go back to this section later on. Right. So for now, I'll be really brief. And then I'm going to only talk about the functional properties and then transitive properties. Only those two. Okay? The rest of them you can read. If you don't understand, it's fine, but just skim through it. Okay? And then let's talk about the functional properties. Okay? The idea of the functional property is, let's just give you the example. Okay? Before so you remember. My teaching method, especially for this topic, is what? For you, it's going to be learn by examples, right? And for me, it's teach by example. Especially for this topic, this ontology topic, if I just start with some, mathematical definitions and all that, it's, you're not gonna be happy. So on purpose, I chose this learning material, this tutorial, the PISA tutorial, because what I like about this tutorial is they use the examples, right? Pretty much the PISA example to teach you the ontology, teach students ontology. Okay, now the functional property is, I'll just give you an example. Let's say the gene has a birth mother Peggy. So let's just draw the diagram. So here's a gene, right? Gene has the birth mother, right? So this is a property, object property has what? Birth mother. So that's the object property, and Peggy. Okay, so here's a Peggy. And if we declare that, right, if you use a protege, and if you declare this property as what? Functional, right? So let's say we declare that this has birthday is what? Functional. For example, let's say checkbox, functional, right? And when you have another statement, another OWL statement, for example, now Jean has birth mother Margaret, right? So let's just draw another diagram, another arrow. So the Jean has birth mother, right? The Margaret, right? So the Margaret, okay? Since we declare that it has birth mother and then has birth mother as a functional, right? When you run using the protege, especially like when you run a reasoner, the reasoner think that what? Is Peggy and the Margaret is the same person, okay? So these two individuals, right? They are same entity. Okay, so what the functional means is that this property, right, specifically has birth mother property, can have only one value, right? So for them, when you run the reasoner, right, it is inferred that logically it is inferred that what? Peggy and Margaret is the same person, right? So that's what it can be inferred. when you declare has birthday as a functional, right? Okay, so now just go back to the let's move to the next page. So this can happen in OWL because what? Unlike many other language, right? Unlike many other language, it does not have a unique name assumptions, right? So we cannot say the Peggy and the Margaret is, for example, like, I mean, we cannot assume that the entity can have only one name, even though the same entity, we should assume that it can have many names. In such a case, we can, provide some constraints, like a functional. If we declare has birthday mother as a functional, that means this property can only have one value, right? So when you have, for example, right? When you have the Peggy and Margaret, right? And then if you use has birthday mother as a functional, right? Then your reasoner, right, can, it can be inferred by your reasoner that this Peggy and the Margaret is the same entity. Okay. Now, okay, please read the rest. And I'm going to skip the inverse function property, but please just read. And now let's talk about the transitive property. This is very important property. Okay. So I think we're going to use these transitive properties when you build the multi-level security policy. So this is, oops, hold on. Okay, so this is very important property. Okay, so let's just read about it. If the property is a transitive, right? P related, relates individual to A and B, and also individual to B to C. Then we can infer that individual A is related to individual C via property P. Okay, so this is called a transitive property. So a good example is, so Dia has an sister Fatima, right? So this is like, if it's A to B, right? So if this is A is related to the B, and then Fatima has ancestors Arjun, right? So let's say this is a C. Then what? A, the Dia has ancestor what? Arjun, right? So, so for example, the transitive property is in mathematics is like greater, right? So if X is greater than Y, and Y is greater than Z, and of course X is greater than Z, right? This is a good example, right? So like in summary, right, the transitive property means if A is, let's say, have some relationship with the B, and, right? And okay, if A and B are related by the property P, right? And then B and C are related by the property P, right? The via property P, then what? Okay, so this is like if, right? If A and B are related by P, and B and C are related by P, that means what? And this P is a transitive, right? If the P is a transitive, then what? A is related to C by property P. Okay, so a good example is this. For example, if 10 is greater than, let's say, 12, right? And then 12 is greater than what? Is 20, right? That means what? Okay, you know what? Let's just. Okay, so a good example is in mathematics. This greater than is great example of transitive, relations. For example, if 10 is greater than 20, and this is n sign, okay? And then it's 20 is greater than 30, right? We know that it's 10 is, of course, is greater than 30, right? So this relationship in math, right? Greater than relationship is a transitive. Okay, so this is a great example. Okay, so that's the transitive properties, right? And I'm gonna skip symmetric and asymmetric properties and reflexive and irreflexive and etc., right? So, but I mean, if you have time, just please read through, right? Although you don't understand 100% is fine at this point. But please make sure that you understand the functional properties and transitive properties. Okay? For now, those two properties are most important to understand. My next topic is the an OWL property domain and range, and this is very important topic. Okay? So thank you.